Hi there, this is Amit and I am a solution architect. In this video, we'll discuss what is programming, types of programming, then we'll talk about the types of programming in detail. We'll also discuss what are the programming approaches and differences between them. Let's start then. As we are studying computers, so we must have heard names like programming and programming languages. So what is programming? If we take a closer look at programming, it has a word program in it, which means instructions. So programming is a set of instructions that is used to perform any task. For example, for a child, programming is to get up from the bed in the morning, brush teeth, take a bath. Now, this is a conditional instruction which says if summer, bath with cold water, and if winter, bath with hot water. Then wear a school dress, have breakfast, and go to school. In the above example, these are the instructions to perform a task. Similarly, in computers, to solve any problem or performing any task, we need to tell the computer the set of instructions which we call programming or computer programming. For example, adding two numbers, calculate the interest on deposits, etc. Let's now understand types of programming languages. Programming languages are categorized as low-level programming languages and high-level programming languages. Low-level programming languages consists of machine language and assembly languages, whereas high-level programming languages consists of procedural and object-oriented languages. Let's see each of them one by one. First is machine language. The instructions in this language are in bits, which are 0 and 1. This language runs directly on the computer CPU. Writing instructions in this language is tedious and hectic, and that is why it is very error prone. This language is specific to a particular type of machine, which makes it non-portable. That is, you cannot create a machine language program which can run on different types of machines. The language is hence is specific to a particular type of a machine. Note that all the languages needs to be translated to the machine language only to execute, because computer understands only this language. Next is assembly language. Assembly language uses mnemonics to perform the task. For example, if we want to add two numbers, so how we will do it is, we will give these instructions to the computer, which is MOV, which is move, EX is register, comma 5, which is value. So it says move 5 to EX register. Then we will say move EBX 8, which means load 8 to EBX register. Now add EX, EBX and ECX. This statement represents add EAX and EBX and store the result in ECX. This language also runs on the CPU directly. Writing instructions in this language is less tedious and less error prone. This language is also not portable like machine language. Examples of this language are Fortran and Algol. Now, first in the high level language list, we have procedural languages. Procedural language programming. In this, instructions are divided into procedures or functions. It is like a divide and conquer approach which do the refinement at every step. It gives instructions in logical steps. It is based on the top-down approach. We'll understand this in the next few minutes. Examples of these procedural language programming are C and Visual Basic. Now the next language is object-oriented programming. In object-oriented programming, the system is designed around data or objects rather than functions and logics. The system focuses on what needs to be done, whereas in the logical programming, the system focuses on how a task is performed. In object-oriented languages, it is based on the bottom-up approach. We'll understand this in next few minutes. Now the example of object-oriented languages are Java, C++ and .NET. Now let's talk about the programming approaches which we discussed in the high-level languages. So programming approach is how a problem is handled or a plan for system creation. So it is basically dealing with these approaches basically are dealing with the planning of the system. There are two approaches. One is top-down approach and other is bottom-up approach. The top-down approach deals with the decomposition of a bigger system into the smaller subsystems, and this approach continues the same procedure until we reach the subsystem or base that cannot be subdivided. Let's understand this approach with a real life example. Let's say you need to make a house. With this approach, we decide the exterior of the house first. After that, we design the rooms of the house and then we reach for how much land we would be needing. So with this approach, we started with the overall objective, which is building a house. After that, we subdivide the house in subsystems and then we look for the land size, which is the base and cannot be further subdivided. Now, with the bottom-up approach, it deals with the merging of smaller subsystems into a big system. With this approach, we start from the base system and merge subsystems to create a complex system. Let's understand it with the same example that we have taken in the top-down approach. So with this approach, we first look for the land that we need and decide how big the house we want to make. Then we decide on rooms, that is the number of rooms, dimension of the rooms, etc. Then in the end, we create the outer structure of the house by combining the above. Now let's have a quick look at the differences between the two approaches. So the top-down approach focuses to divide the system into subsystems, whereas in the bottom-up approach, the focus is to merge subsystems to create a bigger or a complex system. In the top-down approach, each part or each subsystem is separate, so redundancy or duplicacy may happen. Whereas in the bottom-up approach, redundancy or duplicacy can be minimized by data encapsulation and data hiding. We'll be studying these concepts in the series. In the top-down approach, decomposition takes place, that is dividing the system into the subsystems, as we looked at the first point. Whereas for the bottom-up approach, composition takes place, which means combine multiple subsystems into one. So guys, If you want to understand any other computer science topic, let me know in the comments. Signing off for now. We'll meet you in the next videos.